Write a Python function to find the max of three numbers. In this question, we define two different functions. Of course, it is possible to solve this problem with another methodology or algorithm, but here I would like to show that you can pass a function inside of a function. That function gives the maximum of these two values. If this x value is larger than y, then this function returns x, otherwise that returns y. Definition of max of 3 function, it returns a function, the previous function, and this function takes one of these values, and max of 2. Let me try to tell you what is exactly going on here. When I call this max of 3 function, x is gonna be 3, y is gonna be 6, z is gonna be -5. This function is going to give the maximum of x is 3 and maximum of y and z. Since this is y and z, this doesn't have to be y and z. But whenever I call this max of 2 function with y and z, x is going to be equal to the first value and y is going to be equal to the second value. So from this function, 6 and -5 will be passed to the max of 2 function. Since 6 is greater than -5, this function is going to return 6. The same function will be called again, but this time the values are 3 and 6. If condition fails because 3 is not greater than 6 and this max of 2 function returns us y value, which is 6. This max of 3 function returns us, as a result of this function, it returns us 6. Problem 2. Write a Python function to check whether a number is perfect or not. Perfect number means when you sum all of the factors except for itself. It was supposed to give the number. We have a function which is called perfect number, and now I would like to check if 6 is a perfect number or not. We know that 6 is the perfect number, but I would like to be sure if I'm writing the code correctly. 6 is a perfect number because the sum of 1 plus 2 plus 3 is equal to 6, and these are the only factors. Right now, I'm going to sum all these factors, and the sum at the beginning is 0. X is not going to take the value of n. This means that up to n. So if x can divide n with a 0 remainder, it means that x is a factor of n. So with this statement here, I'm adding x value to sum, and we return this condition if sum is equal to n or not. If it's equal to n, if sum is equal to this number n, it means that this number is a perfect number. Let's try with number 7, which is false, and because 7 only has one factors, it is 1 and it's not equal to 7. But when we check 28, it's also true. The factors of 28 gives the sum of the factors of 28 gives 28. This is an industrial engineering topic. Write a Python function to calculate economic order quantity of a supplier. This supplier has a demand 1000 and a holding cost 0.1 and a fixed cost 10. To be able to calculate economic order quantity, we need a formula, which is square root of this calculation over here. To be able to use square root, we have to import math and we have to use square root function from math module. Name of this function is EOQ, and whenever I call EOQ with these parameters, it was supposed to give me the optimal quantity. I pass these amounts to the function, and function calculates a Q amount, then we return Q. For example, if I have a 10,000 demand for a year, it tells me that I'm supposed to give an order of this amount. If I give a smaller order, then fixed cost is gonna be too much. If I give more than this amount, then holding cost make my total cost higher. Question number 4. Given a text and a pattern, write a function that prints all occurrences of the pattern in text. We have a text and we are looking for a pattern and the location of that pattern, where it starts. My function gets two arguments. The first one is the pattern and the second one is the text. So right now, for me, m is the length of that pattern, n is the length of that text. So n is larger than m. Latest point I'm going to check for that pattern is that since the length of that pattern is 4, I was supposed to go backward, and the latest part I'm going to check that pattern is this A. I don't need to check this pattern if that pattern starts from B or not, because the number of letters remained at that point is not equal to number of total letters I have in that pattern. That's why the I here starts from 1 and it keeps going up to this last letter. This can be also found with this formula. The first index that I'm going to look at is 0. Right now, j is equal to 0. While this j is smaller than m, which is length of the pattern, I keep checking the first letter of text and the first letter of pattern. If they're equal, I am adding 1 to the j value. And now I'm checking the second letter of each. If this is equal, I'm adding a 1 value. The same occurrence keep happening, then at the end the j is going to be 4, but here we will be out of this while loop because it says while j is smaller than 4, and then we will print pattern found at index I, because right now j is 4 and m is 4, and this condition is satisfied. For the next step, this time I will check if we can observe the same pattern starting from index 1. We will keep searching for the same pattern by dragging the starting point to the right. 5. Write a function that takes a list and return the list in sorted order. There is also a predefined function sort for this operation, but we would like to do it by writing our own algorithm. Here, first we have an index. This index starts from 1 because to be able to make a comparison, I need two numbers. That's why instead of starting from 0, I start this from 1. Value is just a temporary variable. And now right now, the value is equal to 3 because index is 1 and the value is equal to 3. And now the I variable is going to be index minus 1. And that shows us I is going to be 0. And while I is greater than 0, because otherwise I cannot use this, while I is greater than 0, if this value is smaller than list I, if 3 is smaller than 5, that's what it means. And now list I plus 1, which is the position of 3, is going to be 5. And now 5 is going to be here, 5 is here, and then list I is going to be value, which is 3. Now they are swapped. Other thing you can do here is swapping. We just change their position if this condition is satisfied. Then we are going to drop the I value by 1, and now I was 0 and it's now -1. That's why we're going to be out of this while loop, and we will still in this for loop. And now index is going to be, index was 1, now index is 2. And the value is list.index list2, which is 6. And the I is index -1, now is I is 1. If our value 6 is less than list1, which is 3, that's no, then we break. Now I is 1. While I is greater than 0, if our value, which is 6, is less than list I, you know we swapped in the previous iteration, because now in list I, in ith position there is 5 here. What we need to do here, this is going to fail because 6 is not smaller than 5 and this while loop is broken. We will keep checking, and now we have index value is 3 and the value is list 3, which is 1. I is 2. If 1 is smaller than 6, these are going to be swapped. We will drop I value, and now it's gonna check again. Value is still 1. If 1 is less than, and now there's 5 here, less than 5, yes, it's gonna be swapped again, and then I is gonna be dropped. At least it's gonna check the first number over here, and since 1 is smaller than 3, it's gonna make this swap again, and I is gonna be -1, and we will be out of this while loop. Since we finished all of the, since also we are done with the for loop, we're gonna return the list. As you can see, this is an easy way to do the swap. In question 6, say you have an array for which the ith element is the price of a given stock on day I. If you were only permitted to complete at most one transaction, if A is equal to 0, if A is empty, this means that if A is empty, then it's going to return 0. Our buy index is 0 and our buying price is right now is 7, the first element of the array, and our profit is 0 and our selling index is the same index with buying index. That's the default, that's the starting point, and we will see if how we can improve this. Now if AJ is greater than buy, so the 7 itself is not greater than buy, so we fail here, and now buy price is against 7. And now J is 1, and J is 1 means that, and our value is 1. AJ is not greater than buy, and then our buying price right now A1, which is 1. So the J here right now is 2. AJ is greater than buying price? Yes, because 5 is greater than 1. And AJ minus buy, 5 minus buy was 1, greater than profit? Yes. And then our new profit, 5 minus buy. And our new selling index is 2. And our new buying index was the previous one, A dot index, and the buy price. This index gives us the index of that particular item. Still in this for loop, and now j is 3. So yes, 3 is greater than buying price, but 3 minus 1 is not greater than profit, so this one failed. So j is 4, this is 6. Of course, it's going to give us this 6 minus 1, largest than profit. Profit was 4. With the new value, nothing is going to change, and our buying price is going to be 1, and the selling price is going to be 6, and the maximum profit is 5. Problem 7. It's a knapsack problem, my favorite kind of problem. We will apply some dynamic programming approach here. The question is, write a function that solves the 0, 1 knapsack problem and returns the maximum total value. It is kind of a question, what kind of, which items would you take with you if you're going to an island or something like that. And now you have a bag, and this bag has a capacity. You have some items, some choices. These items has a value and weight. So you cannot put all of them into your bag. You have to find a way to calculate the best combinations of those items. For this, we are writing a function which is knapsack over here. This knapsack function gets the capacity of the bag, weights of the items as an array, values of each item as an array, and number of items. Here we have 3 items. These are the values, and these are the weights of the item, and this is the capacity my bag can take. And we are calling knapsack function. If n is 0, I'm not going to put any items into my bag, or I cannot put any of them because my capacity is 0. I told you that we're going to work with dynamic programming. It means that start from the latest point, or here start with the last item, which is the item that gives us the value 120 and weight 30. If this is larger than our capacity, what we need to do is again calling the knapsack function without the last item. The weight of the last item less than the capacity. Then if I include this item, I'm going to earn the value here, and plus I will solve another knapsack problem. Now I have less capacity. This is the remaining capacity. This is the weight. This is the value. And now again, my number of items is dropped by. If not including this last item is the maximum, it gives me the maximum value. It means that our capacity is the same, the weight list is the same, value list is the same, number of items is again dropped. I'm not considering taking the last item into my bag, which is something like that. Let's say I called one of these, I called the knapsack function with this, okay? And now n is going to be equal to n minus 1. Or let's say I called the function with these arguments. N is going to be equal to n minus 1. And the capital W is going to be equal to this. Let me show you what is really going on behind this algorithm. If you cannot set your mind at the beginning, this method will really help you. And then you will start thinking about in an algorithmic way. First, we check if n is equal to 0 or W, the capacity, is equal to 0. So these conditions doesn't satisfy. Second if condition in our methodology, in our code, is if the weight of the last item is greater than the capacity. So this is not satisfied as well. Here we are creating a tree, and the first option is including item 3. If we include item 3, it means that value of this item will be added to the knapsack problem that will be solved with these parameters. The value of the third item is 120, and after that the remaining capacity is now 20 because the capacity of the weight of third item was 30. And we pass these arrays as they were. We are not making any changes, but now number of items now n minus 1, which is now 2. The other option is not including item 3, and here everything is same. There is one difference. Right now this is n minus 1 and this is 2. We will call the function with these values. And this is the point where we start from the beginning of the while loop again. We will check the if condition if n is equal to 0 or the remaining capacity is 0, so none of them is true. We will check the last item is larger than the remaining capacity. This is not true. So then we will continue. And now we will decide if we are going to include item 2 or not include item 2. If we include item 2, this will bring us its value, which is 100, and then we will call the knapsack problem again with these values. So now we don't have any more capacity. The remaining number of items is now 1. If we don't include item 2, we still have capacity 20. These are the same, and the remaining number of items is 1 time. We do the same checks, and this time, since this capacity is 0, then it returns 0. But for this branch, this still continues. Let's say we calculated for each of them, and this is the fourth time the while loop is running. So the original return function is maximum of including or not including. So let's go back to that. So this function returns 0. This function is now equal to 0. And as total here is 60. Including item 1 gives us 60. Not including item 1, this is 0, and 0, this is equal to 0. It's 0. And now maximum of including or not including item 1 is now 60. So not including item 2 here, 60. Including item 2, this is 0, this is 0, 100 plus 0 is 100. Including item 2 is 100. Not including item 2 is 60. Maximum of these 100. 100 will go up here. This is 100, and including item 3 is 120. So including item 3 gives us the cost 220. We will follow the same procedure here, and we will see what is the cost for not including item 2. And here, the maximum of these values will rise up there. And this is going to be our optimal solution.